we need to grade, and we have a homework where it might have been hard to make it match. We have a homework where it might have been hard to make it match, and so your whole emotional calculus, you might be like, yeah, I'm not feeling it right now. But let's see how you're doing on some more fundamental things from section 2.3, which works on or builds on 2.2, and 2.4 builds on 2.3, builds on 2.2. If you notice, calculus just kind of keeps building. So you have a rock hard foundation, and part of that is knowing that we have the basics. And so the basics, here we go. What should be the nice basics question? Let's start with number 139. There's some concepty questions. Those get tricky. So let's do the basics question. Number 139 says, can you find a derivative, right?
Yes.
And as soon as you read that function, you should have been reading the function and saying 4e to, oh, I did start recording, good. 4e to the x times cotangent of x, right? What should that make you think? Product. So right away, product rule. If you know that, you know a lot more than you knew last year. Hey. So product rule says, you guys tell me the words and I'll fill in the math. Ready, set, go.
Second.
I like his derivative. Plus.
Versus negative.
So I could put a negative there, right?
Yeah.
Now I'm going to pull out my green pen on purpose because guess what? Is there anything in common? We can pull out a 4e to the x. And some of you might not have thought of that until you started looking at the answer choices. Do you guys see, though, how they had one with the 4e to the x's kind of in?
Whoa.
And then they had ones with them out. You should have seen the ones with them out and said, wait a minute, is something in common? Oh, it is. They're just putting that one because it'll look kind of like yours. And you're like, well, those aren't it because there are no parentheses. Well, there should have been if you had simplified. Okay. And then we have cotangent of x minus cosecant squared of x. Oh my goodness, that perfectly matches with
C. Yeah, I got it right.
Careful. Just a few of you. You write the right answer and you make a match too quickly. On your test corrections, you might start seeing this. You get an answer and you're like, yay, it looks similar. And you might be like, actually, okay, you're lucky. Neither of those started with cotangent. But this one, if they had written it the other way, if I was an AP guy, I would have totally written it the other way because then you would have had cotangent plus cosecant squared. It would have matched up with how they would have normally solved it just with the plus. Just be careful that you're making the right match. Yeah? What's another kind of basic one that doesn't have necessarily tons of concepts in it? How about 140? He's a little nasty. What are you supposed to do? Find the... But to find the second derivative, you have to find the first derivative. So let me go over here to find the first, and we'll come over there to find the second. X squared minus x divided by what rule? So quotient rule at the top and at the bottom. So you guys tell me the words, and I'll fill in the math. Ready, set, go. Woo! I would not go for the second derivative yet. We want to simplify, right?
Yeah, I have a question.
Yeah.
So after you simplify, you're going to get another fraction.
That needs another quotient.
But if you look at your answer, I know this is probably a bad idea.
It's dangerous. Oh, this is so
But if you look at the answers and you know that the bottom gets squared.
But sometimes it can reduce with the numerator, and so they have it to the fourth power, but really the third power is the right one.
Nice.
No. That's perfect. That's perfect. Yeah, the AP guys know that you're going to try and skip steps and be like, oh, it has to be, when really all along it's like, oh, it's something simplified. Not always, but very frequently.
Oh, yeah.
Very frequently.
It's X plus 5.
Certainly not.
Oh, thanks. We'll put it on Kyle distracting you. Okay, so
Wow.
we have 2x squared minus x squared. That's a 1x squared. Super dangerous. I'm just saving on space. You should never do what I'm doing. You're welcome. Plus 10 minus 1 is 9, and I know you guys can double check me and make sure I'm right, because you already did it, right?
Yeah.
So plus 10 minus 1 is 9, and then plus is 10, right? Whew, because we're distributing that negative. No killing of seals today. And then we have our minus 5. Double check, are we okay?
Yay.
But that's only my...
First
Look at them, they're so mean! Right?
all that.
Oh! Don't pick C.
No.
Hey.
I picked C.
And I don't think D is it either, but okay, we'll keep going. Why? Because it's the same numerator? Like, what are the odds of that happening? Okay, we have to go again though, right?
I think it's gonna be A.
What am I going to do, Top? You think because you solved it, or you think because you're guessing? Ah, don't guess.
Because what you said.
Bottom, D, top. Sorry, you guys, that's your job. Go. Bottom.
Bottom.
Right, so to go again.
Sure. Yeah.
Okay. Sorry, bottom.
This is disgusting.
D, top.
2x plus 10.
Minus.
Top.
X squared plus 10.
D.
Don't we have to do a thing?
Okay. Here's what's nasty. Isn't that technically a chain rule?
Oh my
Okay,
god.
so there's no
But
chain
wait. So what would you have done in this section if you had seen this? You would have FOILed it and then taken the derivative. That's gross. I mean, you could have x squared plus 10x plus
Foil.
29.
That would be easier.
Yeah, it might have been. But chain rule just says bring down the 2, which I could put in front, right? We put all coefficients in the front. Bring down the 2, keep the u,
Yeah, those
and then times u prime is just 1. Oh, okay, well, that's not that bad. All over bottom.
Squared.
Squared. Yeah, there's a plot. I know. He's actually been in here since yesterday. He's not really slowing
Wait,
down.
he landed me like 3 times.
Yeah. Oh, he was here yesterday morning? Oh, no, after school. He got in here during lunch.
I'm sorry, Addie. What's the last? They're multiplying.
Oh, x plus 5, because I brought down, it's d bottom. So u squared, the derivative of u squared is 2u times u prime, and u prime is just 1. Because derivative of x plus 5 is 1 plus 0. But now we need to simplify, yeah?
Yeah.
Why am I pulling out my, Kyle, remember how I said they like to simplify?
Yeah.
Why am I pulling out my green pen and telling you to look at these?
X plus 5.
There's an x plus 5 in common. Guys, get out a highlighter. This is exactly what I was talking about when I first started teaching the green pen trick. This is the type of problem. Now, there's another type that's even more common. But this is one of them where it's like, don't FOIL, you're going to get third-degree polynomials that you don't know how to factor.
Yeah,
Don't FOIL. Don't FOIL. You're going to get third-degree polynomials that you don't know how to factor. Take out the x plus 5. Do you see it?
Yeah.
X plus 5 and x plus 5, take them out. And when you take them out, guess what gets to happen with the x plus 5s down here?
Oh.
They reduce. So you end up with a ding, 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 an x plus 5 cubed. Because this one goes away, and this one goes away with one of these. Now, that was very dangerous for me to do, but I didn't kill any kittens because there was one in each of them, right? So I could have factored it if I had tons and tons and tons of space. I could have factored him out and then simplified him. It's legal. Now I can distribute, and I get something like, let's see, 2x squared plus 10 plus 10 plus 20x. I'm just doing it the long way so you guys see everything. And then I have a minus 2x squared. Oh my god!
Minus.
So, and it's a Friday, my voice is dead. Minus 20x. Oh my goodness, I can't
Plus 10.
plus 10.
Say speed over X plus 5.
Woo! It's nice. Yay!
Yay.
Having an x plus 5 to the first power, there's no way a fourth degree is going to get down to a first degree. That would have been very practical. And then this one happens to match that one. To be honest, I would have guessed A also. But a lot of you would have guessed C or D because you're like, no, it needs to be with a fourth power. I'm sorry. That was the first derivative. You probably guessed D and then totally wrong.
Totally wrong.
Pause. Do you see the green pen
Yes.
trick? If you didn't see it, it would have been a third degree polynomial x cubed. How do you factor? We've had to do synthetic division, long division, something.
Oh boy.
So look at why you, for the chain rule, why you put the 2 in front of it.
I was doing on this one, Abby, I was doing triangle prime when I was doing that, right? I was doing the d bottom. And so remember you have a u squared down there. And the derivative of u squared is 2u times u. So I had to bring down the 2, remember, the outer. Bring down the 2, keep the u, and then u prime. If you did it the other way, it would be y equals u squared, u equals x plus 2. So I do 2u times u. And that's why the 1 is there, because technically his derivative is just. Okay, we have 2 concept-y questions. The time is running out. Let me just give you the answers to these ones, because concept-y questions, let's just say you just need a continued exposure to. If f is differentiable at x equals c, doesn't that mean the derivative exists?
Yes.
Okay. So we know, just real quick from our forever card, that means that f prime of c exists, and f of c is continuous. Because if a function is differentiable at a point, it must be continuous, right? Okay, so, hey, well, forget that. That's a definite. The limit as x goes to c, well, that's part of continuous, right?
Yeah.
Okay, cool. And then f prime of c is defined. Cool. Has to be d. Oh, that's easy. Because all those had to be, careful, true. All of those had to be true. The only one that could be false is f double prime. I don't know. Number 144. Oh, I don't even have space for an answer blank. How sad is that?
141.
Oh, yeah, thank you. Awkward. 144 is a nicer number, 12 squared. But not the number that's there. Let f of x equals sine of, okay, we need to zoom in, sorry. Did you guys figure out what that weird notation is? If it says f to the nth power, pause, I said that horribly wrong. It's not f to the nth power, it's the
Nth derivative.
Oh, so it could be like the 20th derivative, or the 30th derivative, or the 2nd derivative, or the 1st derivative? Yes. Okay, nth derivative. What is the least positive integer for where? AKA, what is the first time? Do you see it?
Yes.
The least positive integer. What is the first time this happens? What happens? The derivative equals the function. Well, let's start deriving and maybe we'll figure it out. It's trig. Trig kind of like oscillates. So f prime, derivative of sine is cosine. Derivative of cosine is negative sine. Is that the same thing?
No.
Okay, go again. Maybe n is 2. Derivative of cosine is negative sine. Derivative of sine is cosine. Is that the same? No, the negative's not with the... Alright, maybe n is, we could start using either the 3 tick marks, or we can start using the spiffy notation of the third derivative. Derivative of sine is cosine, and derivative of cosine is negative sine. Maybe the fourth derivative. There are strategies that would get you eventually there, but to be honest, I think it's faster just to derive. Derivative of cosine is negative times a negative, positive sine, and derivative of sine is woo! That means B. Oh, but do you know how to do it? B.
No.
How to do it? D C A B. CalcAB. Don't memorize that because that's going to help you. All right, so let's go grade real fast. Chain rule. We got to use. Oh, I had space to actually solve them. Well, that was fun.
That's awkward.
That's okay. We fit it in because we're cool like that. Let's just delete that page. Could have been way more awkward. Like yesterday when I left my lights on and my car died, and then Jose gave me a jump and then accidentally bumped the car door and it locked me out as my car was running and all my stuff was inside. That was awkward.
What?
Then I went walking into the gym with 2 different shoes on. That was good too. Okay. Speaking of awkward. We'll have that ready in a second. Alright, cool kids. Ooh, that's dark. Whoop. Section 2.4, let's grade evens. As I'm turning to the evens, as I'm turning to section 2.4a, which means there's a 2.4b, check out the back board. It's where we're going today, but we're not finishing. Homework is due on Tuesday, but you might want to start. We'll talk more about homework in a second as well, but as we get ready to grade, we should probably just quickly review the chain rule. So the chain rule.
In words or in...
If I am given an f of g of, why not, h of x, how are you supposed to find the derivative? What were you guys using in homework last night? Which of the 3 different representations were really kind of for in the forever part? Words? Who else used words? Raise your hand. The derivative of the outer, keep the inner times derivative of the inner. Cool. What else did you guys use?
Multiplication.
Multiplication. So multiplication unlocks. So thinking of like y prime times u prime times v prime. Who would use y prime times u prime times v prime? Okay, so yeah. You were doing that. Hopefully the rest of you did your homework. It's kind of awkward. It looks like only half of you did it. How would we derive? Well, if you're using the words or if you're using the y equals, could we say y is equal to f of u, and then u is equal to g of v, and then v is equal to h of x? If you did it that way. We could have said, hey, he's the outer, and then he's the next guy, and then he's the next guy. And all we have to think about is times, right? So whether you're doing the words, whether you're doing the snazzy notation, or whether you're doing the y's and the u's and the v's, either way, we have to think derivative of the
Inner.
outer, okay? Derivative of the outer, keeping the
Inner.
rest of the stuff the same, right? Keeping it, and then we do times. Peel off. For those of you guys that did the other notation, this would be like y prime. Okay, what goes next?
G prime.
Yeah, peel off the f. Now it's g's turn, and keep whatever's inside the g still there. For those of you guys doing this notation, it would be times u prime. And then how would we finish this off? Peel off one more time. And then we would say times this guy's prime, which those of you guys doing the other notation, it would be v prime. And then you have, with multiplication, unlocked each of the layers and all of the primes, because the last thing would be x prime, which is 1. So we get to be done as soon as we get to the x's. All right, chain rule, derivative of the outside, keep the inside the same times derivative of the inside. Yep, prime. Here we go, number 6. All you were doing was writing it the snazzy way with u's. Oh, hey, it's a u cubed, where u is ln. They wrote it backwards, what I would have done. I would have gone here first and then the other. They just went the other way. Either way, it's a u cubed where u is ln. Number 8, oh, you were actually deriving. Number 8, you were actually deriving. But, did you guys see it was really a 5u to the 4th? How do I derive 5u to the 4th? Easy, 20u cubed times u prime. So, 20u cubed times u prime. And then what's all the rest of it? Rewriting it, simplifying it, making it look pretty. Like, he's not in a cube, let's bring him in front. Yay, done. Wait, why did the negative magically turn into a positive? I disagree with this.
Yeah, I think
That's what
I think it's just a typo, right? Why would they write it? It is.
Yeah, it should be negative.
There's the answer. Yeah, they just wrote it. That's weird. Why would they? Yeah, there's.
Hello. Hello.
Oh, what do you see? That's different. Do you see it?
What?
Oh,
What did they
x
do?
squared. They switched.
This isn't standard form. So they said, now listen, they said with a cube I could pull out a negative. Oh, thank you. I feel bad. We finished our project. Well, I got you ready. I was thinking I have no change, but it turned out like that. I think it's fine. I'll be like, I sold as many as I could, and I'll take it back to them. Anyway. He pulled out, and he pulled out. They pulled out, could have been a he. They pulled out a negative. They pulled out a negative 1, and a negative 1 cubed is still a negative. They were legal. They pulled out a negative 1 cubed is still a negative. They pulled it out to make everything pretty. Well, wait, because you have made it match. Because I bet one of the answer choices would have had it like this with a positive. And it would have made you rethink all your decisions. You're like, well, it can't be that one. It should be a negative. Number 20. Uh-oh, now there's awkward boxes. Number 20. And number 50 and number 72. Just so you guys check. Let me know if you have any questions. Let me get rid of that. Oh, number 20 didn't use the quotient rule? Could you have? Yes. What did they use instead? Rewrite power rule.
Yes, you can rewrite that.
They rewrote power rule, but quotient rule should have landed you in the exact same spot. And this one you were actually so lucky because the U prime was 1. So if you had forgotten the chain rule U prime, you would have still been fine. That rare. Number 50, did you guys figure out the outer layer was secant, whose derivative is secant tangent, keeping the inner the same, then times U prime, which is 2x, which I put in here to make it look pretty. Oh my goodness, I wish green pens worked. Do they work? Oh, yeah, it does. Why am I pulling out my green pen? You can pull out an e to the negative x and an x. Check it. If I were them, I think I might have also pulled out a negative to make it x minus 2. It's a little bit more proper. And then, number 106. Oh, no, we don't want my picture. Ah, I'm going to clear the ink. Go away. Okay. Did you guys do it right? Or did you get tricked by the trig notation? No. Did you think about the sign board that's still up there because I wanted you to look at it again today? Sine squared is sine of x inside a squared. So who was that? Yes, because it's a very important thing. Do you think of it like that? Because it's the same thing.
Opa.
So y is equal to the outer layer, and then the next layer, and then the next layer. So we take y prime times u prime times 2. If you're making mistakes, do it this way, because this way says who squared? U squared. 2 times what? 2u, and u needs to be, well, sine of v, so you make sure you get the 2. Sine of not x, but 2x. Cosine of not x, but 2x. If you're making mistakes, this way will save you as long as you plug in correctly. Because it's 4 sine of 2x, cosine of 2x. Woo, all right. Do I have more evens? Oh my goodness, one more. 112. Thank you, thank you. Final answer, did you get it? Negative 5 over 32. Not a decimal, because you shouldn't have been using your calculator.
Oh, yeah.
If you did, well, okay. See if your decimal's right, and don't use your calculator next time. This would have been a non-calculator question. Because they didn't give you decimals. They gave you a fraction. Oh, you didn't have to plug in the y anyway. Didn't you just have to plug in the x? Yeah. But some of you still were scared of that. Alright, guys, I love y'all, and I would love to do homework questions right this second, but I think I'm going to let you sit with the even answers and the things that you had to mark wrong over the weekend and ponder them a bit, like you would ponder the odds. Don't you also have the work to the evens in the YouTube video from today to check out? Come Monday with what chain rule problems still don't make sense. First thing Monday, we'll go over questions. Sound good? Yeah. Why? Because I want us to start 2.4b, the final section before the next test.
test.
The final, oh, so good, so good. It'll be Monday's warm-up. Oh, so good. So good. It'll be Monday's, I don't know, something.
Andrea.
Yeah, it's nice. We're doing 2.4b today, doing 2.4b on Monday, which is why that homework is due on Tuesday. We're starting the test review Tuesday, continuing the test review. I think we're going to have 2 days on Wednesday, test on Thursday. Our pattern will pretty much be 2 days of test review, and here's the reason why, guys. 1 day will be you guys do a test review bookwork and come with questions. 1 day will be you guys do a test review bookwork and come with questions. And the next day is we do practice multiple choice and see where you go wrong. Does that make sense? You'll have a bonus practice test again that you can work on. I really like something I'm doing in BC. I just don't know if it would be too much for you. Because they're doing an AP classroom multiple choice like testing scenario in class on their phones. And they have like 1.2 minutes per multiple choice. They don't have to write down questions. They're just trying them. And then as a class, we see as a class which ones we missed the most and go over them. I like the idea of multiple choice can mess you up. So let's try a few together in like a testing situation and see where we went wrong. But you never know exactly what they're going to give you. If they give you some weird concept-y ones, I don't want you to stress over those right before a test. Maybe we'll stick with the practice tests instead, because I know what questions are there and I know they're helpful. But maybe we'll do the AP classroom thing after you take the test. That way the test is over. You don't have to be like top of your game mental-wise. And the concept-y ones won't totally stress you out. Does that sound good? Okay. These concept-y ones are good for AP, but I don't want to kill you for your test. I just decided.
Oh, the first one's infinity. Yeah.
Oh, yeah. Let me zoom in. Sorry. The first one's infinity.
Oh, that's so. I don't know.
Well, it was really thin. Like the equations, there's no way to make them bold.
They're your eye roll.
Why do I have a graph?
Wow, thanks.
Because I want you to remember how logs work. Hey guys, you realize, I know this is log base b of x, but couldn't it be log base b of u?
Yes.
And if it was like x minus 2, wouldn't there be some shifting to occur?
Yes.
If there's shifting that occurs, your domain will change and your vertical asymptote that every logarithm has will move to. And your intercept that always happens at, didn't we need this the other day? 1. Because any logarithm of 1 is always equal to 0. Now it could be 1 outright when x is 1, or it could be when u equals 1 if there's a u. Anyway, remember real quick with logarithms, domain. U needs to be greater than 0, and technically, log base b of u when u equals 1 is 0. Boop. That's what I just went over. As we go to infinity, what does log do? As x approaches infinity, what does any log do? Remember, limits are heights. Where do the heights go? Yeah. Now very slowly, but yeah. Just going to keep on rising, just very slowly. And then why do I have x approaching 0 from what direction? From a little above? Because I can't come from below, because there's nothing below unless I have an absolute value thing that says, sure, come on over. As x approaches 0 from above, what's the logarithm doing? Because what is present at 0? Vertical, which is why the domain is greater. Asymptotes. But what's here at the bottom of the page, now that we can read the top of the page? Oh, wait! Logarithm doesn't exist if x equals 0, or we could say if u equals 0. There's a vertical asymptote. Okay. Oh, okay. Sorry. My first property was log of 1. That's all right. But what are the other properties down there, guys? Why are they in green?
They're
They're review and they're pre-calc and algebra 2, right? Sure. Sorry, I didn't actually.
Sorry.
Log of 1 is 0. What do I do if I have two things multiplied together in a logarithm? How can I rewrite it?
Split them up.
I split it up and I put a plus. Oops, well, I need.
Use your P.
I know, it's like my sin all over again, right? It's log of. I need an of, everybody. Log of P plus log base P of Q. How about if I'm dividing?
Subtract.
Not minus Q. No. Then if I have a power to a power, oh, I'm just kidding. I mean a log to a power.
You take them. It's actually kind of like the power rule.
It is. That's exactly where it comes from.
Oh.
Because if I'm multiplying like bases, I end up adding their exponents. If I'm dividing like bases, I end up subtracting their exponents. And if I'm raising a power to a power, I multiply. And this is all because logarithms are actually exponents. Okay, so they come from the exponents of exponential functions. It's something we covered in pre-calc. It probably didn't stick, but Miss Delvo came in the other day and she was like, man, those logarithms. I just remember she only went up to a certain level in math, and she was like, all I remember from that entire class is logarithms are powers. I'm like, they are. I don't know what that means. I'm like, well, but they are. Anyway. Logarithms are powers. That's why they have these really cool properties. And I need you to highlight them because they're super important. And we're going to use them this year, but this is not calculus. These are not derivatives. And why am I saying that? Because check out the power rule to logarithms. Doesn't it look like I'm deriving? But I'm not.
Subtracting them.
Well, yeah, these ones don't really look like derivatives, but this one does. These are not derivatives. This is good old-fashioned pre-calc. Remember how sometimes they might change 2 sine x cosine x to be sine of 2x?
Yeah.
That's not calculus, that's pre-calc. You know how sometimes they might simplify complex fractions to make it pretty? That's not calculus, that's pre-calc. They might start rewriting logarithms. It's not derivatives, or at least not yet. It's just using properties. We have cool properties to help us rewrite stuff, and it's going to be super helpful. I just need you to realize with logarithms, there's also understood parentheses here, whether or not you put it, right? Speaking of understood parentheses, I think, CalcAB, was it in homework last night you saw sine of x squared? Yeah. Last night when you saw this, what did it have to mean? There's only one way of reading it.
Parentheses.
Where were the parentheses? They weren't there. Yeah, but they're understood. It's sine of x squared. Question, what if I was to write something like this? Where are the parentheses?
X plus.
You have to go with what's written. And what's written is sine of plus 1. If they wanted the rest, they should have shut it in. PEMDAS says, well, the ofs before the addition. So that's weird because it's like parentheses and multiplication. The ofs before the addition. If they wanted that, they would have had to close it in. I know. It's weird. Okay. Ooh. Hey. We have a derivative rule. Ready?
Okay.
What's the derivative of e to the x? We've already done him. E to the x. We like him. He's easy. What's the derivative of ln of x?
X down.
1 over. Was it in the summer review packet? Yeah. A lot of these rules were in the summer packet, just some of you didn't pay attention. Or you didn't memorize it, and it's okay, you didn't have to. Derivative of ln of x is 1 over x. Wait, that's it? Yeah. So you know what's cool? We could also say from that, now that we know the chain rule, can't we say the derivative of ln of u? You guys do what I did yesterday? Pause. What's the derivative? 1 over u times? Now you can do any e to those and any ln ofs. What you can't do is log base 2s or 5 to the x's. But there are rules for those if you guys want to check them out. Actually, do you guys want me to put a forever card on there for any of you guys doing homework? CalcAB, it is pepperoni schedule. It is kind of weird, so you're getting out early. But if you want... Oh, never mind. I'm sorry. It's not filled out. Bummer. If you want another video, at the very end will be your next forever card and your last forever card if you guys want to start memorizing it. But you don't need to stay. You can go ahead and go if you need to.
Won't you stay a second on a hater? Bye, John.
My God.
Alright, there's the forever card if you want it. Bye, guys.
Oh,
Kyle.
it's Friday. You write an essay about how to darkness now.
Have fun.
Just
Just think, you're welcome. Just think the darkness of the human heart. Works pretty good. Human depravity.
You basically got to end the weight of lies.
Yeah.
Give me the fatty because it lasts.
I think we'll come in during fourth period after during nutrition to join back on. Wait, when's the pep rally after fifth?
Yeah, right before lunch. Right before lunch.
So I'm gonna be dancing on an empty stomach.